Finally, we are now in the last quarter for this school year. And to begin with, we will be discussing lesson 1 of unit 4, measures of position for ungrouped data. Specifically, we will be focusing on quartiles, deciles, and percentiles. So let's first begin with quartiles. So quartiles are the score points which divide a distribution into 4 equal parts. Again, quartiles are score points which divide a distribution into 4 equal parts. So if this is the whole distribution, it is divided into 4 parts, in which in this position, it is where the first quartile located, while this position is where the second quartile located, and in this position is where the third quartile is located. First quartile in percentage is also equivalent with 25%. Second quartile is 50%. And the third quartile is the 75% of the whole distribution. Now, the first quartile is also called the lower quartile. The second quartile is called the median. And the third quartile is called the upper quartile, in which that means 25% of the data is less than or equal to the first quartile, while 50% of the data is less than or equal to the second quartile, and 75% of the data is less than or equal to the third quartile. So let's have an example. Say the owner of a coffee shop recorded the number of customers who came into his cafe each hour in a day. The results were 14, 10, 12, 9, 17, 5, 8, 9, 14, 10, and 11. Find the lower quartile and upper quartile of the data. Again, we're going to find the lower quartile, which is the first quartile, in the upper quartile, which is the third quartile of the given distribution. Okay, so let's first try to analyze the data manually. So here's the procedure. Step 1, remember that when you are dealing with measures of position, step 1 is always arrange the data. Okay, now step 1 will be arrange the data in ascending order. When we say ascending order, from least to greatest. So from least to greatest value. Okay, now next, say here are the number of customers in a day in the cafe. So we have 14, 10, 12, 9, 17, 5, 8, 9, 14, 10, and 11. And with that, you have to arrange this from lowest to greatest, or from least to greatest in ascending order. So let's begin with the smallest data is 5. So 5 comes after 5 is 8. And then we have 9 2 times. We have 9 2 times. And then we have 10 as well, 2 times. 10 2 times. We also have 11 once. And we also have 12 once as well. And we have 14 2 times. 14. And lastly, we have 17. So, arranging the given distribution from 14, 10, 12, 9, 17, 5, 8, 9, 14, 10, and 11, it will now become 5, 8, 9, 9, 10, 10, 11, 12, 14, 14, 17. Do not forget that this is always the first step in identifying the positions of a distribution. Okay, specifically in ungrouped data. Now next, step 2, determine the least, middle, and the greatest value in the data. So here's the data. Which among this data is considered the least value, the middle value, and the greatest value in the data? So technically, when you say list, it is the smallest value. And in the given data, 5 is the smallest value. So 5 is the least. Next, middle. How about the middle? Middle is located at the center of the whole distribution. So we have 10. How did we know that it is 10? You can do the takip-takip method. You know the takip-takip method. So by pairing, so from starting with this distribution paired with the distribution on the right. So pair this and then cancel out. So pair, tapos na. That means that those pairs are not considered located at the middle. Okay, next. One pair here, cancel out. And then cancel out. 9 cancel out. 10 and 11 cancel out. So 10 remains here. Therefore, 10 is located at the middle. Okay, that is what we call the takip-takip method. Okay, just kidding. Next, how about the greatest? The greatest is located at the last. Since the distribution is in ascending order, therefore, the largest value is 17, in which this is now considered the greatest value. Okay? Now, from there, determine the lower and the upper quartiles using this distribution, in which 5 is the least value, 10 is the middle value, and 17 is the greatest value. So automatically, 10 is considered the second quartile. So this is now your second quartile, okay, or the middle value of the whole distribution. Now next, as for the lower quartile, in the distribution below, the lower quartile belongs here, in this part. They must be less than the second quartile. Okay? So, paano gagawin yon? You can also do the takip-takip method here, starting in this distribution. So, 5 and 10 pair, 8 and 9 pair. So, you will live with 9. Therefore, the lower quartile is located at 9. Okay? This is the lower quartile. Okay? So, 9 is the lower quartile. So, the lower quartile is the value that is between, sabi niya, the middle value and the least value in the dataset. Okay? Now, next. How about this one is considered now the second quartile, in which the second quartile is the value that is in the middle of the whole distribution. Now, next, as for the third quartile, this must be greater than the second quartile. So we're talking with the values that is greater than the middle distribution, which is 10. Okay? Since 17 is the greatest, automatically this is not your third quartile, in which one of this data or one of these scores is considered the third quartile. Okay, so with that, pair ulit tayo. So, 11 and 17, 12 and 14, and 14 remained. So, this is now your third quartile. Okay? So, the upper quartile is the value that is between the middle value and the greatest, should I say. I forgot to edit this out. This should be greatest. Correction, this is greatest. Okay, I forgot to edit it out. So, the upper quartile is the value that is between the middle value and the greatest value in the set. So, given this, let us now interpret the whole distribution. So, find the lower quartile and the upper quartile of the data. Therefore, the lower and upper quartile of the data are 9 and 14. Okay, so that's how you analyze the whole distribution manually. Now, how about using a method called Mendenhall and Sinsich method? So, using this method, the upper quartile and the lower quartile values are always two of the data elements. So, that means the values of the upper and the lower quartile always two of the data of elements of the whole distribution. Say for example here. So say first quartile, we're looking for the first quartile. The first quartile must be one of these elements. Say 5 is the least. So this is considered 1%. So when we say one of the elements, automatically one of these 4 given data is considered the first quartile. While on the other hand, this data is considered the upper quartile. So yun ang ibig sabihin nito. Okay? So when we use Mendenhall and Sinsich, automatically the values are always 2 of the data elements. Okay? So what is now our working equation? So let's begin with the lower quartile, or sometimes denoted as big letter L. So for the position of the first quartile, it is located to 1/4 of the quantity of n plus 1, wherein you have to round it off to the nearest integer. When your answer is in decimal, you have to round it to the nearest integer. Okay? Since it is located in the first quartile, automatically if L, or if the lower quartile falls halfway between 2 integers, automatically you have to round up. So for lower quartile, round up. Next, for upper quartile, the position of the upper quartile or the third quartile is equal to 3/4 of the quantity of n plus 1. In which, if your answer is decimal, you have to round it to the nearest integer. But then, if the upper quartile falls halfway between 2 integers, you have to round down. Okay? Again, lower quartile, you have to round up. Upper quartile, you have to round down. Okay? So let's continue. Let's have an example. Say same distribution tayo with regards with the coffee shop. Okay? So let's first identify what will be our n. By the way, I forgot to tell you, n here is the total number of distribution, total sports, or total items in the whole distribution. Okay, so first things first, given the distribution, you have to arrange it in ascending order. Since our given is already in ascending order, let's proceed with the given. So given natin n is 11. How did we know that it is 11? Just simply count all the scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 11. Okay. Next, working equation will be the first quartile. So, because we are looking for the first quartile first. Okay. So, the position of the first quartile is equal to 1/4 of the quantity of n plus 1. And then, just simply substitute. N will become 11. So, we have now 1/4 of the quantity of 11 plus 1. And 11 plus 1, that is 12. Okay? And then, simplifying the whole thing, 12 divided by 4, that is equal to 3. Okay? So, that means that the position of the first quartile, or the position of the lower quartile, is located at the third element. Yun ang ibig sabihin nito. Okay? So, the lower quartile is located at the third position in the data. Okay? Now, let's identify what is that data. Okay? Where is now the lower quartile? Sabi niya, the position of the lower quartile is located at the third element in the data. Third element. So, just count 1, 2, 3. Automatically, 9 is considered the third element. Okay? So, therefore, the first quartile is 9. Okay, so that's how you use Mendenhall and Sinsich method. How about 9? So, how about the third quartile? So, again, you have to identify n. N is 11. And you will be using the third quartile, which is equal to 3/4 of the quantity of n plus 1. Now, if you are asking what will be the formula for for the second quartile, say first quartile is 1/4 of the whole distribution. Correct? Now, second quartile is 1/2. 1/2 of the whole distribution. So, 1/2 of the whole distribution. Or you can also use 2/4 of the whole distribution if you don't want to use it. But simplifying 2/4, that is just simply equal to 1/2. Next, the upper quartile or the third quartile is equal to 3/4 or 75% of the whole distribution. Okay, so let's compute the upper quartile for the given distribution. So for the upper quartile, we will be using 3/4 of the quantity of n plus 1. Now you have to substitute the value of n inside the given formula. So n now will become 11. Okay, so we have now the 3/4 of the quantity of 11 plus 1. And 11 plus 1, that is equal to 12. And then multiply 3 and 12. Or you can also simplify 12 and 4 if you like. For the meantime, let's proceed with the operation. So 3 times 12, that is equal to 36. And 36 divided by 4, that is equal to 9. So therefore, the position of the third quartile is located at the 9th element of the whole distribution. Again, the upper quartile is located at the 9th position or 9th element in the data. So you will be counting 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, 14 is the upper quartile, or 14 is the value of the upper quartile. By the way, to avoid confusion, the term position is different from the value, from the term value. Some problem are asking for the value of the lower quartile, the value of the upper quartile. But some problem also asking for the position, just for the position. So in this case, if you are asking for the position, the answer is 9th. Okay, so the upper quartile is located at the 9th element or 9th position of the whole distribution. Now, what is the value of that 9th position? The value of that 9th position is 14. Therefore, the upper quartile has the value of 14. Okay, now next, another example. Say, find the first quartile and the third quartile given the scores below of 9 students in their mathematics activity using, the first one is using Mendenhall and Sinsich method. The second one is using linear interpolation. Okay, so the distribution is 1, 27, 16, 7, 31, 7, 30, 3, and 21. So first things first, you have to arrange the whole data in such a way that it is in ascending order. So from smallest to greatest, or from the least to greatest, from smallest to largest. Okay? So we have 1, 27, 16, 7, 30, 31, 7, 33, and 3, and 7, 1. Again, 33 and 21. Okay? So let's begin with 1. Comes after 1 is 3. And then 7. Twice, and then 16, we have 21, 27, 30, and 31. So as arranging it in from least to greatest, it will become 1, 3, 7, 7, 16, 21, 27, 30, and 31. Okay? After arranging it, identify how many or what is the total number of the scores, or what is the total number of the given data. So we have 9. So n is 9. How did you know that it is 9? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? Now next, locate the position of the score in the distribution. Again, we will be using n is 9, and we will be using 1/4 of the quantity of n plus 1 for the first quartile or the lower quartile. So by substitution, n now will become 9. So we have 1/4 of the quantity of 9 plus 1. And 9 plus 1, that is 10. So 1/4 of 10. And 10 divided by 4, that is equal to 2.5. Now, remember that if you are using Mendenhall and Sinsich method, if L or if the lower quartile falls halfway between two integers, round up. So, you have to round up 2.5. Rounding up 2.5, that is approximately equal to 3 since you round up. Okay? Therefore, now, the lower quartile is located at the third position in the data. Okay? Third position in the data. Now, you have to count. 1, 2, 3. So, automatically, 7 is what we are looking for. So, this is now the position of your first quartile. And the value of the first quartile is 7. If you will be using Sinsich method. Okay? Or Mendenhall and Sinsich method. Now, next. As for the upper quartile or third quartile, same process, but we will be using 3/4. Okay? So, 3/4 of the quantity of n plus 1. And then substitute n with 9. So that we will now have 3/4 of the quantity of 9 plus 1. And 9 plus 1, that is 10. And 10 times 3, that is 30. So, 30 divided by 4, that is 7.5. Now, since we are dealing with the upper quartile, according to the given Mendenhall and Sinsich method, we have to, if U falls or if the upper quartile falls halfway between two integers, you have to round down. So, round down automatically, the whole number will retain. So, this is approximately equal to 7 and not 8. Okay? So, if upper quartile falls halfway between two integers, you have to round down. Okay? So, therefore, the upper quartile is located at the 7th position, 7th element in the data. So, count 1, 2, 3, 4, 5, 6, 7. So, 27 is considered the upper quartile. Okay? Now, next. With that, we will be applying linear interpolation. Okay? Since the given value of the first quartile and the third quartile is not a whole number and they are decimal, that means you have to proceed your computation with linear interpolation. Okay? So, let's try linear interpolation. So, find the first quartile and the third quartile given the scores below of 9 students in their mathematics activity using linear interpolation. So, same data tayo, 1, 27, 16, 7, 31, 7, 33, and 21. First things first, arrange the given data in ascending order. So, we have from 1, 27, 16, 7, 31, 7, 33, 21. We will now be using 1, 3, 7, 7, 16, 21, 27, 30, and 31. Okay? In which n is also 9. Next. Ayan, excited yung sagot. Next. So, locate the position first using quartile 1. Substitute n, that is 9. 9 plus 1, that is 10. 10 divided by 4, that is 2.5. Now, since the result is a decimal number, ito yung sinasabi ko. Since the result is a decimal number, you have to proceed with linear interpolation. Okay? Again, if the computation of your first and third quartile is in decimal, you have to proceed with linear interpolation as continuation of your computation when it comes to finding out what is the exact value of the first and the third quartile. Okay? So, here are the steps for linear interpolation. Given the distribution 1, 3, 7, 7, 16, 21, 27, 30, and 31. So, we know that the position of the first quartile is located at 2.5, correct? So, if we are just using Mendenhall and Sinsich, automatically, this is approximately equal to 3, correct? So, the position of the first quartile is located at the third element. But then, you're looking for the exact value. Since you are looking for the exact value of the first quartile, you will be using linear interpolation. Okay? So, the position of the first quartile is 2.5. And the decimal part of 2.5 is 0.5. So, removing the whole number, you will left with 0.5. That means that is the decimal part of the position of the first quartile. Okay? Next, 2.5 here means you are dealing with the second. So, 2.5, so counting it 1, 2, and 2.5 is here. It is between 3 and 7. Okay? So, that means that the value of the first quartile is located between the values 3 and 7. So, ito yung ating first quartile. Itong mga values. Ano yung mga values na yan? 4, 5, 6, and so on. So, in short, since 3 and 7 is in the given data, we will be using the second and third position, the second element and the third element in answering the whole distribution using linear interpolation. Okay? So, proceed. So, the second position, the value of the second position is 3 and the value of the third position is 7. And with that, we will be proceeding with the first step in linear interpolation. Sabi niya, subtract the second data from the third data. Lagi bang second data, lagi bang third data? Hindi. Tinitignan mo kung ano yung nakuha mong sagot dito. Okay, say ang sagot mo dito for instance is 6.5. If your answer here is 6.5, automatically you're dealing with the 6th position and the 7th position. So, magbibilang ka nun. 1, 2, 3, 4, 5, 6. Ito yung pang-6, ito yung pang-7. Yun ang gagamitin mo. Okay? Since ang nakuhang computed value natin ng first quartile is 2.5, we will now be using the second element and the third element. Okay? So, the third element in the data is 7 and the second element is 3. So, you have to subtract the second from the third. So, that is 7 minus 3. And 7 minus 3, that is equal to 4. 4 now is the difference between 7 and 3. Okay? In which that difference will be used in second step, which is multiply the difference by the decimal part of the computed position of the first quartile. Remember that this is the decimal part of the position of the first quartile. And you have to multiply it with 4. That means 4 times 0.5 or 0.5 times 4. And 4 times 0.5 is equal to 2. Okay? That is equal to 2. Now next, last step. You have to get the value of the first quartile. How to get the value of the first quartile? Add the result in B to the smallest, add the result in B. Add the result in B to the smallest number value in A. So, add mo daw yung sagot mo sa B dun sa pinakamaliit na value na given sa A. Okay? So, that is equal to 3 plus 2. Paano naging 3 plus 2? Si 3 kanina, siya yung smallest value in A. If we will go back to the previous slide, so, second element is 3. Ito yung second element natin. And third element is 7. Okay? Ano yung mas maliit sa kanilang dalawa? The smallest value between the two is 3. Okay? So, ang gagamitin mo sa C yung smallest value. Okay? So, 3 is the smallest value in A and 2 is the result in B. After you multiply the difference with the decimal part of the position of the first quartile. Okay, so 3 plus 2 is equal to 5. Therefore, this is now the exact value of the first quartile. So, the first quartile or the value of the first quartile is 5. Okay, so using linear interpolation, makukuha mo yung exact value ng first quartile. Okay, now next. As for the third quartile, same process. But we will be using 3/4 of the quantity of n plus 1. Okay? So, substituting it, n is 9. So, 9 plus 1, that is 10. And then 10 times 3, that is 30. Divided by 4, that is 7.5. If you will be using Mendel-Holland Sinsich, you have to round it down or retain the whole number, which is 7. Correct? So, you're dealing with the 7th element. But then, you want to find out what is the exact value of the third quartile. You know that the third quartile is located at 7.5th element of the whole distribution. So, since the result is a decimal number, interpolation is nila. So, let's proceed. Using linear interpolation. 7.5 or 7.5th is the location of the third or the position of the third quartile. And the decimal part of 7.5 is 0.5. While since this is 7.5, that means you're dealing with the 7th position and the 8th position. Again, you're dealing with the 7th position and the 8th position. Now, you have to count. Nasa dyan yung 7th position, nasa dyan yung 8th position. So, 1, 2, 3, 4, 5, 6, 7, 8. So, 27 is the 7th position, while 30 is the 8th position. In short, since the third quartile is located at the 7.5th position, ibig sabihin yung values na nasa gitna ni 17 at saka ni 30, yun yung value ng ating third quartile. So, hahanapin natin yan. Okay? Using linear interpolation. So, first, subtract the 7th data from the 8th data. So, that is 30 minus 27. So, 30 minus 27, that is 3. See, 3 now is the difference. Now, for the second step, multiply the difference by the decimal part of the computed position of the first quartile. The decimal part is 0.5 and the difference is 3. So, that is 3 times 0.5, which is equal to 1.5. And then you will be using 1.5 to add it with the smallest value here. Ano bang may smallest value? Ang 7th o yung 8th position? Ang 7th position, tama? So, 27. So, eto dito, sa last position, i-plus mo yung 27. Okay, dun na tayo sa C. So, that is 27 plus 1.5, which is equal to 28.5. Therefore, while 27 is the smallest value in A, 1.5 is the result in B. Therefore, 28.5 now is the value of the third quartile. The 28.5 is located at the 7.5th element of the whole distribution, which is in between 27 and 30. Yun ang ibig sabihin nun. Okay? So, again, the value of the third quartile or the upper quartile is 28.5. Okay? What if you do not want to follow, you do not want to write down everything? You want a fast computation. Try natin ito. So, 1, 3, 7, 7, 16, 21, 27, 30, 31. So, kung ang hanap nyo dyan ay first quartile, automatically, 1/4 yun ni n plus 1. Tama? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, n is 9. With that, ito magiging 9. So, we have 10 over 4. Tama? And 10 divided by 4, that is equal to 10 divided by 4, that is equal to 2.5. So, this is 2.5. Okay? Pagkakuha mo kay 2.5, mag-A ka na agad. So, kung 2.5 yan, that means second and third. Okay? So, second and third. 1, 2, 3. 1, 2, second, 3. So, second ito, third ito. So, that is 7 minus 3, which is equal to 4. Okay? Tapos, si 4, i-multiply mo dun sa decimal nito. Ang decimal nito ay 0.5. Okay? Times 0.5. 4 times 0.5, that is equal to 2. Okay? Tapos, last na lang, si 2, i-plus mo dun sa mas maliit. Sinong maliit? 7 or 3? Itong 3 ang mas maliit. So, 2 plus 3, that is equal to 5. So, conclusion ka na nun. Therefore, the value of the first quartile is 5. O, tapos ka na nun. Para less sa sulat, no? Next, third quartile is 3/4 of, n is 9, 3/4 of 10. Tama? And this is 33. Or should I say 30? So, 30 divided by 4. And 30 divided by 4, that is equal to 7.5. Okay? 7.5 yan, ang hanap mo ay yung pang-7 at saka yung pang-8. Okay? 3, 4, 5, 6, 7, 8. So, pang-8. Ulit. At 3, 4, 5, 6, 7. Pang-7. Ito, pang-8. Okay? And the decimal part of this is 0.5. So, A, 8 position minus 7th position. So, 30 minus 27, that is equal to 3. And then, 3 times yung decimal part, 0.5. 3 times 0.5, that is equal to 0.5, 1.5. And then, yung anong mas maliit dito sa dalawa, 30 o 27? 27, ano? So, we have 1.5 plus 27 or 27 plus 1.5 kung ano mas gusto mo. So, that is 28.5. Therefore, the value of the upper quartile or the third quartile is 28.5. Okay, and that's it. We are still in lesson 1, measures of position for ungrouped data, but this time we will be discussing deciles and percentiles. Let's start with deciles. So deciles are the score points which divided a distribution into 10 equal parts. Again, deciles divide the whole distribution into 10 equal parts. This is what looks like when deciles divided the whole distribution into 10 equal parts. Okay? Now, for the working equation, the thought of solving or the process of solving quartiles is the same with deciles. But the only difference is that in quartiles, the distribution is divided into 4. While in deciles, the distribution is divided into 10 equal parts. Okay, so the position of the unknown, K is for the unknown decile. Ito yung hinahanap mong value ng decile. Okay, N is the total number of scores in the given data. Okay, ilan lahat yung nasa data. Okay, now next, so again, the working equation in finding out the unknown decile is equal to K over 10 of the quantity n plus 1. Okay, so let's have an example. Find the third decile. So this is K. You are looking for the third decile. So this is K. Of the following test scores of a random sample of 10 students. Scores of 10 students. So this is N. Okay. So here are the scores. 35, 42, 40, 28, 15, 23, 33, 20, 18, and 28. So first things first, you have to arrange. Okay. So arranging it, starting with 15. And then 18. Again, when you arrange it, it must be in ascending order. Okay, so we have 20, 23, 28 2 times, 33, 35, 40, and 42. 40 and 42. Okay, next. After arranging it, you have to find the location of the position of the score in the distribution. You're looking for the third decile, correct? So, for the third decile, you will be using the given n, which is equal to 10, kasi 10 lahat yung score. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And the value of your k is 3 because you're looking for the third decile. And then, for the working equation, the unknown decile, the position of the unknown decile is equal to k over 10 of quantity n plus 1. Okay? Now, substitute n with 10 and k with 3. So, we have now the position of the third decile is equal to 3 over 10 of quantity 10 plus 1. Okay? So, 10 plus 1, that is 11. And 11 times 3, that is 33. 33 divided by 10, that is 3.3. And 3.3 is approximately equal to 3. So, the position of the third quartile is located at the third element of the whole distribution. Okay? So, nasan dyan ang third element natin? Kung third to, ibig sabihin this is located at the third element. So, 1, 2, 3. Okay? So, ayun ang ating third decile. That means that the third decile is located at the third element, or should I say the third decile is located at the third element. Okay, and that third element is 20. So therefore, the value of the third decile is equal to 20. Lastly, let's talk about percentiles. So percentiles are the score points which divide the whole distribution into 100 equal parts. 100 equal parts. So 100 equal parts, that is considered percentiles. Okay? As for percentiles, this is what the distribution looks like when we are dealing with percentiles. So in relation with quartiles, quartiles will divide the whole distribution into 4 equal parts, correct? So 25% of the whole distribution is considered 1/4. Tama ba? So 25% is considered equal to 1/4 of the whole distribution. In reference with first quartile is 25% of the whole distribution eh. So therefore, the value of the first quartile is equal to the 25th percentile. Okay? Because first quartile is 1/4 of the whole distribution, and 25th percentile is also 25%. Okay, that's why they are equal. And in terms of second quartile is 50% of the whole distribution. Therefore, that is equal to the 50th percentile. So quartile 2 is the same with 50th percentile of the whole distribution. And as for the third percentile, that is 3/4 of the whole distribution, or 75% of the whole distribution. Therefore, third quartile is equal to the 75th percentile. Okay? Now, with reference to the distribution of decile naman, one decile is equal to 10%. 2 decile is equal to 20%. 3 decile is equal to 30%, and so on. So therefore, the value of the first decile is 10% of the whole distribution when it comes to percentile. So first decile is equal to 10th percentile. Okay? The second decile is equal to 20th percentile. Yun ang ibig sabihin yan. Okay? For the working equation, they have the same idea, but instead of 4 and 10, the whole distribution will be divided into 100. Okay? So the working equation now will be the position of the unknown percentile is equal to k over 100 of n plus 1. Where in case the unknown, n is the total number of scores. Okay, let's have an example. Say, find the 30th percentile. Find the 30th percentile. So this is k. Of the following test scores of a random sample of 10 students. So 10 students, this is n. Now these are the scores: 35, 42, 40, 28, 15, 23, 33, 20, 18, and 28. So first things first, you have to arrange the whole data in ascending order. So to start with, we have 15, 18, excited yung aking kamay. So 18, we also have 18, 20, 23, 28 2 times, 33, 35, 40, and 42. So ito na yan. After arranging it, we will now be using the arrange distribution in locating the position that we are looking for. We are looking for the 30th percentile. Okay? So n is 10 because we're dealing with 10 students. And case 30 because we're looking for the 30th percentile. If we will be solving this using decile, 30% is equal to third decile. Okay? So kapag nahanap mo na yung third decile, pareho na sila ng 30th percentile. Okay? So proceeding, say tapusin natin siya using percentile. Working equation will be the position of the unknown percentile is equal to k over 100 of n plus 1. Substitute all the given values. N will be 10, k will be 30. So we will now have the position of the 30th percentile is equal to 30 over 100 of 10 plus 1. Actually, you can already do cancellation here. 0 and 0. Okay? But, pakita muna natin yung diretsong computation. Okay? So, 10 plus 1, that is 11. And 11 times 30, that is 330. Divided by 100, that is 3.3. And 3.3 is approximately equal to 3. Therefore, the position of the 30th percentile is located at the third element of the whole distribution. Okay? So, ang 30th percentile natin, nakapwesto siya dun sa pangatlong element ng distribution. And what is that element? That is 20. Therefore, the value of the 30th percentile is 20.